Hello pre-calculus students, and welcome to the continuing lesson on areas under curves and velocity and time and distance. So here we'll look at this example. A rocket is launched with a velocity function v of t equals 500 minus 32t squared. The velocity is measured in feet per second. Now, those of you who know physics and know the Earth, this equation doesn't really apply to anything that's on Earth. But I've chosen this equation here so just to help us understand what we're working with, and in order to really have a solid theoretical foundation. So I've made up this somewhat contrived problem, but it'll help us solve it. But by solving this, we'll be able to solve some of the more practical ones. Okay. So how far has it traveled between 0 and 2 seconds? Well, I want to refresh your memory and remind you, if you haven't seen the previous video, that if I have something that is a velocity function, and this is time in seconds, okay, this right here is velocity in feet per second. Then if I want to find distance, then the distance is the area underneath the curve. And I will point to this quickly here to refresh your memory. If I have a velocity function versus time, then the distance is the distance traveled is the area between the velocity function and the x-axis. In other words, this area right here. Now, in our previous example, the area was easy to do because you had a nice, perfect rectangle to solve. This one or this one. Here, it's a little bit more difficult because you have a curve. Okay? But we can still do this problem. And the way that we're going to do this is to estimate. Okay? So we're going to estimate. And at this point, you'll probably already learn RRAM, and you should have already learned RRAM and LRAM. If you haven't, you should watch one of the other videos or ask your teacher for some help. Okay, but I'm going to do this by just busting this thing up into a bunch of rectangles. Okay. And I'm actually going to stop at 2 because it's only asking me to go between 0 and 2. So I have 1, 2, 3, 4 rectangles. Okay. Each of them have a base of 1/2. Each with a base of 1/2. So if I want the total area, it's going to be 1/2 or 0.5 times the height here, but this height here is just f of 0.5 plus 0.5 times this height here, and I should say that I'm going to make the rectangles this way. So I'm going to take this and draw them. Whoops, that's my first rectangle, and I'm going to take these points and just draw them in. Okay, and those of you who already learned this is called RRAM. We'll go back to, if you haven't learned this, watch one of the other videos to talk about where that talks about RRAM and LRAM. So we're using RRAM here. 0.5. This rectangle here has a height of f of 1 plus 0.5. This rectangle here has a height of f of 1.5, and then this one here has 0.5 f of 2. Okay. So one thing I can do is just factor out 0.5. Okay. And f here is this function. Whoops, I really shouldn't have used f, I should have used v. This is why you should do math in pencil. So I should say v. And then I can type all of these values here into the calculator, and it'll help me find my answer. So I'm going to do that. So I got my trusty TI-83 here. Type in the equation 500 minus 32x squared, and I'm going to exit out of there. And we're going to use the variable feature here. So vars y vars function y1. Instead of v, it's just y1 now of 0.5. Whoops. Of 0.5 plus y1 of 1 plus y1 of 1.5 plus, whoops, I got it back, plus y1 of 2. Enter, and multiply the whole thing by 0.5. And this says that the area under the curve, the area, is equal to 880. And it's somewhat weird, but this area here is actually the distance. So the distance traveled is about 880 feet. And that's going to be my final answer. Okay. So this video and the previous one is really just an application that explains and shows us that there is a logical reason to find the area underneath the curve, even if this area can mean something different. In this particular instance, if you have a velocity function, and it has to be a velocity function, and then you have something in terms of time, the area underneath the curve gives us the distance traveled. Now, we don't know how to find the exact area yet, and this is actually going to occupy about a semester of calculus, because it's a very complicated topic. But for now, we can at least answer questions and get a pretty good estimation of this. And I did this using RRAM. You could have also done this using LRAM, done it in both ways and take the average. Anyways, thank you for watching. As always, ask for help if you need it. Have a wonderful day.